Hey guys, we are looking at a segment called boats and streams in time and distance. If you have a boat moving on a water body like river, see the boat can be moving along with the direction of the stream in the river, or it could be against the stream in the river. If the boat is moving along with the stream or current in the water, we call it downstream movement. And if it is going against the current or the stream in the river, we call it upstream. Maybe you've heard of these terms, downstream and upstream. Now look at a boat whose speed in the still water. Let's assume B be the speed of a boat in still water. Still water means there's no current or stream in the water. And S stands for speed of the stream. In that case, downstream movement of the boat will have what kind of a speed? The actual speed of the boat in still water gets increased by the speed of the stream, which means downstream movement, the boat will be moving at this speed, B plus S. Whereas in upstream movement, it's going against the current or the stream in the water. That means the actual speed of the boat is getting reduced by the stream speed, which means this will be the effective speed of a boat moving upstream, and this is the speed of a boat moving downstream. So all you have to do is problems dealing with boats and streams, instead of normal speed, you will be replacing it with either downstream movement speed or upstream speed, looking at the direction of the stream in the river or in a water body. That's all you need to remember while tackling problems from boats and streams. We will work out a few simple problems to illustrate this idea of boats and streams. This is a simple problem from boats and streams. A boat traveled upstream 64 meters with a speed of 10 meters per second and then returned to its starting point in 20 seconds. Find the speed of the stream or current. Here we know the speed of the boat in still water, that's given to be 10 meters per second. We don't know the speed of the stream. Let S be the speed of the stream. Then the boat is traveling first 64 meters upstream. Upstream, as I showed you before, will be B minus S. Because it's going against the current. So its speed gets cut down by the speed of the stream. Then immediately it comes back to its starting point. So the distance will be the same. And while coming back, obviously it's going along with the current. Because if one direction is upstream, the opposite direction will be downstream. So in downstream, this will be the speed. Now look at this. This is the distance, this is the speed. So this will be what? This will be the time taken for the onward trip. And this will be the time taken for the return trip. And totally the problem says the boat has taken 20 seconds. We got a simple equation in B, and of course B I forgot to substitute. B is given to be 10. So this will be 10 minus S plus 64 by 10 plus S equal to 20. We got a simple equation in S. All you need to do is to just solve this. 64 is common. So this implies 64 1 by 10 minus S. I've taken 64 out. 20. Now simplify this. 10 plus S. 20. 64. S has gone. So you have 20. This is A plus B and A minus B. So 10 square minus S square. 20. Now this 20 gone. This you take to the right side. Finally you will get 64. This implies 10 square minus 64 equal to S square. On further simplification, you will get finally S is equal to plus or minus 6. Now, speed of the stream is obviously positive. So S will be 6. So many meters per second. So this is the final answer to the question. Let's do one more problem. The next question from boats and streams is this. I cycled 50 kilometers in the direction of the wind in 5 hours and then returned to my starting point taking 10 hours. How long would I have taken the entire trip if there were no wind? Here the distance given is 50 kilometers and the time is 5 hours. Let C be the speed of the cycle. and W, speed of the wind. First is cycling in the direction of the wind. So the effective speed will be C plus W. It's like downstream movement. So this is the distance, this is the speed, and the time taken is given to be 5 hours. This implies what? C plus W equal to 50 by 5 equal to 10. This implies C plus W equal to 10. Now, while returning, he is going against the direction of the wind. So, the distance is the same, but speed of the cycle will be C minus W. And he is taking 10 hours. This implies taking C minus W to the other side, 50 by 10, which is 5. So, we have two equations. Just add them up. You will get 2C equal to 15, which implies C is equal to 15 by 2. So we got the speed of the cycle. The question is about finding what? The time taken for the entire trip. Entire trip means 50 plus 50, 100. Distance for the entire trip will be 50 plus 50 equal to 100. Now they say there is no wind. That means he is going at his own speed, which is found to be C. Distance for the entire trip is found to be 100, and this is the speed at which he is moving. So it will be 200 by 15, which is 40 by 3. So many hours is the time taken for the entire trip. Let's do one more problem from boats and streams. The question is, I swam from point X to Y and back in 15 hours. I dropped my goggles at X and it took 20 hours to float to Y. Find the ratio of my speed in still water to that of the current. Let my speed be X and that of the current be S. So we are asked to find out S by S. We don't know the distance from X to Y, and we are not asked to find out that distance. So let's use some convenient number for the distance from X to Y, which could be the LCM of these two numbers. You can choose a variable for the distance, but it will only complicate the problem. You're not going to get anything different by choosing variable. What about the LCM of 20 and 50? That's 60. So let's 60 kilometers be the distance from X to Y. I swam from point X to Y. That means the distance I covered while swimming from X to Y is 60 kilometers. And we don't know whether it's a downstream. You can choose it as the way you want. You can take it as, what to say, upstream. If it is upstream, speed will be X minus S. Then I'm swimming back. Obviously, if this is upstream, the other one will be downstream. So this will be the time taken for the downstream, this for the upstream. Sum of these two will give you the total time I took, which is given to be 15 hours in the problem. The next sentence says, I dropped my goggles at X and it took 20 hours to float to Y. What does that mean? As soon as I started swimming, by mistake I dropped my goggles and it moved with the speed of the stream. See, it can't swim on its own. So it's floating to the other end of the point, which is Y, with the speed of the stream. And the total distance is assumed to be 60, and S is the speed of the goggles, so moving from X to Y. So this is the distance by speed. That will be the time, and that's given to be 20 hours. This implies S is equal to 60 by 20, which is 3 hours. So we have found out S separately. Now solving this, I put S is equal to 3 in this. It will get reduced to one variable X, which you can easily solve. 60 is common. 1 by X minus S. So X minus 3. S is found to be 3. X plus 3 equal to 15. That implies, this on further simplification, it will be X minus 3, X plus 3 equal to 15. This will be 4. This on simplification, 2x. This will go to the other side. You can write it as x square minus 3 square. This is x, a plus b and a minus b. Here actually it comes like this, 15 and 1. Now this implies x square, this is 8x taken to the other side, minus 9 equal to 0. It's a quadratic equation. You can easily solve it. Let's factorize. 9 make minus 8x. So combining x square plus x, you will have plus 1. Then combining these two, take minus 9, let's take outside, so that inside you get 0. X into x plus 1 minus 9 into x plus 1. X plus 1 common, x minus 9 equal to 0. This implies x is equal to minus 9. X stands for what? That is the speed with which I swam from x to y. So obviously it should be a positive figure. So this gets eliminated. So x is equal to 9. So we have separately found out x as 9 and s as 3. Substitute that here. So x by s will be 9 by 3, which is equal to 3:2. This is the ratio. So totally we have worked out 3 problems based on a simple idea called boats and streams. If there is any point you are unable to follow in the solution I gave you, feel free to raise it in the comment section. I will address it there. See you guys in my next video, where I will be helping you with the smart solutions to problems that are even trickier than the ones I have already discussed. Bye for now.